We'd like to get started. Welcome. Welcome to the last and the best session of PDC, the first day of the PDC. My name is Mike Barnett. I'm a research design engineer from Microsoft Research.
My name is Nicola Tillman, and I also work in Microsoft Research.
And we're here today to tell you about two new projects that are coming out of Microsoft Research and that are available today for you to start using to make your code better. I'm from the code contract side of the house. And what that means is we've introduced a design by contract system that's a library-based solution. That means that you can use it from any .NET language. Today I'm going to show it to you from C#, but you can use it in VB, F#, any other .NET language. And it provides a way for you to capture the intent as you're writing the code of what the correct behavior is for an API. So you can think of this as taking the assertions that you already write. You do already write assertions, right? Who writes assertions in this room? Oh, of course, because you look like good programmers. Good programmers write assertions. But assertions are internal documentation for you as a programmer to remember things at this point in the code. And what code contracts do is they let you lift that to the API level to now express those in terms of method contracts. So that's a requirement that all callers must honor in order to call your methods. You can also tell them things using the contract.ensures method so that they know what things they can expect back from those methods in return. You often need to document internal object state, that if your object's in a good state, certain values should be non-null, certain values should be greater than other values, and for that we provide a way to express object invariance. We even give you a way to write interface contracts so that you can have a single contract on an interface and yet have that contract enforced on all implementations with that interface, which is a really powerful technique. By using our library, you've now standardized how you write your assertions. That means that now, with that one form of assertion, you can apply many, many tools to it. We already have 3 tools available for you today. You can do runtime checking against these assertions. They can be injected into your code so that if a contract is violated, you can decide what to do about it. We have a static checker that will look at your code at compile time and analyze all possible code paths to see if there's any possible error relative to the contracts. And a really great feature is that we can provide automatically generated documentation. This means your documentation never goes out of date. It's always in sync with your code because the contracts are expressed in your code. And you'll see that in just a minute.
So I think code contracts is a really great tool because the more contracts you have, the more assertions you have in the code, and the more assertions you have, the more expressive your tests become. How many of you do unit testing? Oh, at least as many as those who write assertions.
Maybe more than assertions, wow.
Yeah. So I will talk about PEX, which is a tool that helps you with unit testing. So PEX enables a new way to write unit tests called parameterized unit testing. And PEX helps because PEX can generate test inputs. And so in the end, you get an entire generated test suite. PEX also comes with 2 frameworks that make it easy to deal with code that requires interfaces and code that has environment dependencies. Okay.
Well, that's a lot of talking, but I bet these guys being programmers, they'd probably rather see some code. So I think we should just write some code.
What about a web service?
I think web service sounds good. So I think a nice easy thing to program is, there's orders coming in off the web. And we need to process those orders, get them from the warehouse, and ship them out to customers. So we should write this little method here called process that takes an order.
So do we have to write the entire thing, order, class, and warehouse interface?
I think they probably want to get to the party at 5:30, so I think we better start with something already defined. So we'll have orders, we know what's in those, we have the API for the warehouse, we know that how to get something from the warehouse and ship it. We just need to write the little bit of code that orchestrates that API.
Okay, let's do it.
Great, so we're here. So let's see.
So you want to process the order.
That seems like a good idea.
So it has a quantity in it, and so for each item specified in the order, we should remove it from the warehouse. And the order has a product ID. And then I think we can just tell the warehouse to ship it to the customer. The order has a customer username, and the item has an item ID. Am I too fast for you, Mike?
I'm just like the worst typer in the world. There we go.
Okay.
Okay, so we're done.
That looks like very easy code. I mean, I've written that many times. What could possibly be wrong with that?
Well, I usually use tools to tell me if something goes wrong. So I think I'll just build this and I'll look at the error list, and if the compiler is happy, then there can't be anything wrong with it.
Certainly type correct. What else could be wrong?
I don't know. Like I said, I don't really like to think about things. I like to use tools to tell me that. So what I've done is I've already gone ahead and I've downloaded the code contracts tools. And by downloading those from DevLabs, and we'll show you what that is and where to get it later, we get a new pane in our property window that lets us control the tool. And
So Mike, just to understand this, so that's not in the box. I have to download a separate tool?
That's true. It's not in Visual Studio 2010 in the box. You have to go down, download this, install it. You get this nice pane. And I'm going to click this box that does static checking. And that means that upon every build, the static checker will look at the code. Oops. Oh, yes. I should check it. And after I check it, then I will build. And now, after the build happens, and this is one of the reasons we operate on any .NET language, because it really doesn't matter whether I'd written this in C# or VB or F#. We look at the compiled binary, and we notice some issues there that the compiler certainly didn't warn us about.
So because you checked the box, it's now like a post-build step that this checker is running, and it's coming up with all these warnings?
Yes, and if I don't check that box, nothing's going to happen. The tools only get invoked if you opt in and say, please, I'd like to run these tools. So it's complaining about, let's look at the last one. It's complaining about possible null dereference. That's true. Compiler's not going to warn me about that. But certainly at runtime, if I dereference a null variable, I'm going to be in trouble. So let's double click on that and find out, oh, the problem's right there. That seems pretty easy to fix. I mean, it's clear, right? I'm taking a parameter. I didn't do any parameter validation.
Let's do some defensive programming.
Really silly. OK, so we'll just, if the order's null, I guess there's really nothing to do. We can just return.
One way to deal with the issue. I mean, that should prevent any kind of null reference exception.
And if I build again and I look at the error list, it's true that now the static checker looks at it and notices that there's no way that order can possibly be null. We've guarded against that. So it's certainly smart enough to figure that out.
Before we had 3 warnings, and now it's down to 2.
So we're definitely making progress. Let's look at the next warning. The next warning is warning about a null dereference on a store field, a field in my class. Again, I'll double click on that and see what that is, and that's here. But I mean, that seems, in this method, by the time I get to this method, I'm going to have a warehouse. So it seems crazy that I would ever get a null dereference here.
So you don't quite know what the warning really means?
I get a warning that there could be a problem, but I don't know exactly what could cause it. Do you have any idea how to figure that out?
I think I can help you here. So your warnings are potential issues about errors that might or might not happen at runtime, right?
That's true.
And so the other tool we are showing here today is called PEX. And I went ahead and downloaded it before the session, and I installed it. And after doing that, what you get is a new context menu item. So you can just right-click on any method and then say run PEX on it. And what that will do is it will generate test cases. It will run the code with different inputs, trying to figure out how to trigger different corner cases. And what we get back is, first of all, this table. The table contains 1 row per generated test case. For each test case, we have test inputs generated. And in the table, there is 1 column per parameter of the method that we are trying to test here. And we can see in the results that when we pass null, everything works nicely, the test case passes. When we pass an order where the quantity is 0, also everything works nicely. We don't go into the loop.
Right.
But then if the quantity is 1, then we get a null reference exception. That's what the last line tells us.
All right, well, sure. But how does that come about? I just don't see the scenario where that ever happens. Can you show me the actual test case?
So it's really the line where you got the warning beforehand. And yes, I can show you a test case. So first you get the table, but behind every row in the table, there's a test case. To get it, you have to press another button, Save Test. And when you do that, PEX will tell you that it's about to create an entire test project. So there are many steps involved, and you already get a preview of the actual test case that we are looking for. So just have to press 2 more buttons, Apply, and OK. And now a test project is created in the background. We didn't have one before, just the product code. So you can see it's a new test project now. And it contains a reference to the Visual Studio unit test framework.
Oh, so it's tied just to the Microsoft unit test framework.
Here by default it is, but we also support other test frameworks, NUnit, XUnit, you name it.
Oh, that sounds good.
And what's really new here is you get a file that holds generated test cases that trigger particular behaviors. So this is a file holding the generated test case that I just saved, just one. And you see it's a test method, so it's a unit test generated by PEX. And in it, it creates the data that we need to run the code under test. Here it's a web service and an order. And then we call the code under test. So I can now use this unit test to debug the issue. So let me set a breakpoint here where we run into the error. And then our user interface in PEX also comes with an easy-to-use debug button. Let me press that. Well, the debugger is going to launch. Takes a moment. Longer than it takes to generate the tests. OK, so we are now in the debugger. And we can inspect the values. And indeed, the store is null. That's what the little tooltip says. So do you believe me now that this issue can really appear?
I believe it can appear. Let's see the scenario, the test case to see how that came about, where that null showed up.
OK, so if you haven't seen it yet, I think it's pretty obvious when you look at the test case, because we are passing a null warehouse here.
Oh,
Yeah.
I never intended for the constructor to be able to take a null value there.
I think you're right, Mike. So in the constructor, we shouldn't have been allowed to pass any kind of value, right?
So, yeah.
So PEX, when it generated the test cases, it followed the data flow, and it figured out that, indeed, this constructor is the best place to place a check to prevent this issue. So there's another new button here called Add Precondition, and that will insert a check in the constructor that we shouldn't pass a null warehouse, since that causes the exception. So actually, I don't quite understand what this is, contract.requires. That's from code contract side.
That's from the code contract side. That's right. So now you're seeing the first explicit contracts. I talked before about how you can have a method contract. This is now part of the signature. Think of it as part of the API of this method. So this method takes a parameter of type iWarehouse, and in addition to that, that value should never be null. And this is now enforced on all clients so that they don't try to call this method with a null value.
So it's like writing a check, if not condition, then throw argument exception?
That's the old way of doing parameter validation. Writing it this way gives you many benefits. For one thing, we can come in and actually know that this is a precondition, and we can generate documentation automatically for your API that says, for this class, never pass in a null value here. And I can show you other ways that amplify writing it this way as opposed to writing an if test that then throws an exception.
Are there any other kinds of contracts?
Sure. Well, this one talks about the state before the method. But in order to enter it, we can also talk about what the state is at the end of the method. So for instance, when this method finishes, it's the case that the store field isn't null because we're taking a non-null value and storing it in the field.
So you say this condition will be checked after the method finishes?
That's right. So a post condition happens at the exit to the method. You could have as many exits as you want, and then at the end of the method, we'll check to make sure that all the post conditions are satisfied.
But looking at the code, it looks like it's going to be executed before we actually execute the method body.
Yeah, as I said, you have to think of these contracts as part of the API. They're part of the signature of the method. It's our tools that come in afterwards that are going to take care of manipulating the compiled code and putting the checks in at the right places. I mean, I can even show you how that works. Let's get rid of the precondition at first. We'll put a breakpoint in this method.
Then you can use the test case that PEX generated to run the code.
All right, is that hard to do? What do I have to do to go do that?
So you go to the PEX UI and click on the debug button.
Oh, that's pretty easy. OK,
Click
and
it.
now I did.
Oh, OK. There's some interaction with the tooltip. And
There we go. Ah, now I clicked it. Or maybe you clicked it. OK.
only I can click the button.
All right, so go ahead. Run the debugger. See what happens.
OK, so we're in the debugger now. Let me step through the code. Step over. So it didn't execute the ensures. We are now in the method body.
That's right. Like I told you, the post conditions have to happen after the body's over. So the first thing you have to do is execute the body before you go check the post condition.
OK, let's continue. Now we are done. We're at the end of the method.
That's right. So now you're at the unified exit point, because this could be a big method with lots of different return statements all through it. But they're all going to come now. We're at the very time when we're about to exit the method. This is the time to check the post condition. Go ahead and click that button one more time and see if you do.
OK, one more time. Oh,
Oh.
so you really redirected the call.
We take the code after it's been compiled. We rearrange the binary. And so now the debugging experience is exactly what you would expect. You do the code, and then you check your post conditions.
OK, so I believe you now. You can change the order of execution. So now we have two contracts in here that say the store is not null. Does it mean that the static checker that runs as a post-build step can make sure once and for all that it's never null, so that we get rid of that warning?
Well, let me build the solution again, and let's take a look at what the error list says. The static checker is still not happy. It thinks that there's still a possibility that store could be null.
But how can that be? We wrote 2 contracts. All the code fits on one screen. There's no way we can pass this constructor and make the store null.
That's right. But as you saw with PEX, PEX was considering the code that's here and actually executing it. But the static checker is thinking about all possible execution paths. And notice that this field is a protected field. That means that a subclass could be defined that has a different constructor and doesn't set that field to be non-null. So there's no guarantee that this field is non-null. There's only the code here which happens to make it non-null.
So while PEX only looks at the code that exists today when generating test cases, you consider all the code that could be written in the future?
That's right. So what we really want is somehow to say that this field should never be null in this class, in any subclass, and for any method, whether it's here now or it's written in the future as the code evolves. And code does tend to evolve. So we have a way to express that, which is the object invariant, which I mentioned before. So this is, we're trying to say something now that any object of this class, any instance that comes along, should have this property. And so that's expressed with a method that has a special attribute on it that tells us that it's an object invariant. And we're going to put here the fact that the field should never be null. And now this is going to be binding upon all constructors in this or any subtypes. It's binding on all public methods. So at the exit point of every public method, we'll check to make sure that that method has not inadvertently set this field to be null.
So as a post-build step, you will insert calls to this invariant at the end of all of these methods.
That's right. So this is part of the amplification. You have to write these contracts, but you get a lot in return. So you write a little bit, and it gets amplified by being injected into all of the methods that it needs to be there for. In fact, now this post condition is redundant because now all methods have to make sure that store is not null. So we could even delete that, and it's implied by that object invariant. That's a stronger specification.
Cool. So you write it once, and it will be checked in many places.
Yep.
Can you show us whether now it's really guaranteed that the store is never null?
Let's go back and build one more time.
Will we get rid of that warning?
Yep, look at that.
So before we had 2, and now we have only 1 warning left.
So we're down to our last warning. This is warning now about a null reference, again a null reference, but on a variable item. And if I double click on that, we'll see where that, let's see, item comes from, it's the return value from this method. And this method is defined where? Oh, that's that interface method from the warehouse.
Now we have a problem, I think. I mean, we would like to say in a contract that it should be ensured that the result is always non-null. But I mean, how can I write a call to contract ensures in the method body of an interface? Interfaces don't have method bodies.
That's right. So since I can't put it on the interface method directly, we have a way to encode that. So we define what's called a contract class, which is a class whose only purpose in existence is to hold the contracts for an interface. So now I'm defining the interface and linking it up with the contract class. The contract class called it iWarehouseContract. I'll go to its definition. And here, now I can implement my interface. There, and there's a method, and there's remove from inventory. And now I can say that the item that comes back from this method is never going to be null. And now I'm able to write the contract there.
So you didn't quite implement this class yet, Mike.
That's right, because like I said, this class is just there as a placeholder. It's only there to hold the contract so that our tools can think of it as if the contract was always on the interface method. You should never this class will never be instantiated. These methods will never be executed. It's just our tools are going to come along and notice this post condition and consider it the post condition for that interface method. And that's where it's going to be injected into every implementation, that, actual implementation that comes along.
In the future.
In the future, yeah.
And again, you write it once, and it will be checked in many places.
Exactly.
I see.
And so now let's run the static checker one last time. And yep, notice that as far as all of the contracts in that code about things not being null and whatever other contracts we wrote, that all those assertions pass the static checker. And we have a very high guarantee that the code will never violate any of those properties.
Wow, 19 assertions that were checked in code that basically fits on one page. That's pretty impressive. I mean, I didn't know that there were so many potential issues in there. But I'm actually still not convinced that this function is doing the right thing. I mean, we wrote down contracts at the level of individual functions, but overall, is it really shipping the right items to our customers?
Yeah, I think we need to write away a test for that, because I don't think that the contracts do that. The contracts give us a way just to talk about each individual methods API and not about the orchestration of what happens as a use case comes along.
Yeah, I want to write a unit test that exercises a whole scenario and tests the business logic.
All right, I think that's a good idea. Before you do that, though, let me just go back. I'd like to just summarize what people saw here, just so that they don't forget it when you show them your razzle-dazzle stuff with unit testing. Right, so we showed that you can write code, which you already do, but now you can stylize, you can standardize your parameter validation to include contracts instead of the kind of parameter validation code you write today. So you can talk about things that must be true at the method entry. You can add post conditions that talk about things that have to be true at the end of the method call. And by writing it in this one form, you now get the chance to be able to do all sorts of things. Runtime checking, like you saw on the debugger. Static checking, we ran that a bunch. And we didn't have time, but we can also generate the documentation from that. In addition to the method contracts, there are object invariants, which talk about the sort of the steady state behavior of what the internal state of an object should be.
So I write once what should be true for an object field, and you will inject checks in many, many places?
That's right. So you don't have to think about all the different locations things could happen. You have to just say in one place declaratively what that object should be like. And we even have ways to put contracts on interfaces and other abstract methods that are places you can't put method bodies. So we encode them there. Yes?
Is there a way of working out what contracts will be made so easily? Say you've got someone else's code.
Yes.
Can you
Yeah, so the question is, if you have a bunch of code and there's contracts on it, is there a way to know what those contracts are and have them show up? That's part of our documentation tools. So I'm not able to show, I don't have that today to show you. But yeah, we have editor extensions to Visual Studio 2010, which will bring those up in your face and you'll be aware of those. Great, so the interface contract classes are linked with attributes to the interfaces they come from, and then you can write your contracts there. It's all controlled by the Visual Studio add-in that we put into your properties of your project.
So if I wouldn't check the boxes, the contracts wouldn't do anything?
Yeah, let me show you exactly how that works. So by checking everything, that's what we did in the demo. We had full checking on. That means that the first thing that happens is the preconditions are checked, then the body of the method is executed, and then the postconditions are there.
And when I have invariants also go at the end?
Yes, invariants would be at the end along with the postconditions. And that can get somewhat expensive, as you can imagine.
What about the runtime overhead?
Right, so for testing build, this is what you want. You'd like to know errors as soon as they can happen. But when you go to release, you don't want to have to ship all of those extra checks. And so if you just, up there in the top right, you can see instead of saying I want full conditions, you can say I just want the preconditions. And this would be good for a library where you have untrusted clients, where you have to guard against them using your API incorrectly. And you want the parameter validation. So by checking just preconditions, then your code has the precondition checks and then the method bodies. And this is pretty much what your code looks like today, I'll bet. You ship code that has parameter validation and then does whatever the behavior should be.
So it's just the same runtime overhead as traditional if not condition throw exception?
This form of the code is exactly the same behavior you'd get today. So it's the same overhead, but we can do something even better, right? You might be writing a library that has trusted clients where you know that the clients are not going to violate the preconditions. And in that case, by selecting no error checking, this is something you can't get today. You've got all your code in there. It's going to be there whether you release it or not. This way, you just select no error checking, and you just get the body itself, and you don't get any of the contracts checked.
Okay.
The documentation generation works like this. Currently, you already have the compiler generate XML, and then our tools come along and inject. You can see in the red box there that we inject new tags into that XML that have the content from the contracts.
I normally don't read XML to figure out documentation.
I don't think anybody should. I think they should use Sandcastle, which is this great tool that takes that XML documentation and generates really nice looking MSDN style documentation. And when you install our tools, you will get a new set of style sheets for Sandcastle that understands these new tags, and the documentation that gets generated will have these very nice sections for each of the contracts on every method and for each class.
Okay.
Sorry, one question.
Yeah.
Do you make any difference between internal methods and public methods of APIs you write?
The question is, do we make a distinction between internal methods and public methods? Yes, we do, and you can choose that. You can say that you want contracts only checked on publicly visible members, and your internal ones, you know that you're not going to have those. Yes, we try to give you lots and lots of options. And I also should have said that the error behavior when a contract fails is completely configurable. So you might be running code where you want failures just to log something so you can look at them tomorrow. Or you might want the world to stop, and so you want to just tear down the process. That's completely up to you. That you just add some hooks to listen to the events, and every failed contract generates an event, and if you handle it, that takes care of it. The question was about the assume statement. We're going to get to that in just a minute, so if you just hold on with that.
Okay, so if you have any more questions, we will have more questions at the very end. Yeah.
Okay.
Then I can finally do my unit test.
I think it's time.
And I want to do it with PEX. And what PEX enables us to do is parameterized unit testing. In fact, in the background, PEX already generated a parameterized unit test for us. Didn't show you yet. And it's looking like this one. It's decorated with an attribute to indicate that it's a parameterized unit test. It's parameterized because, well, it takes parameters. And in this case, it's basically saying that it shouldn't matter what web service instance we use, what is the order from the user. In any case, when we process an order, we should succeed, and all the contracts we have in place, they should hold. And then I should go in and add more assertions about the business logic. And I will do that in a moment. So in this kind of test, I don't always have to specify all the values that are needed to run the code. Whenever a value shouldn't really matter, I can just lift it to a parameter, and this way the test becomes much more expressive, right?
So you mean PEX is just going to figure out what values to use for those parameters?
Exactly. So just having a parameterized test is of no use because we need inputs to actually run the code, right? And that's where PEX comes in.
So it just generates random junk for those values?
No, PEX actually analyzes the code. It is looking at all the statements in there, the if statements. Whenever there's an if statement, PEX will try to cover both the then and the else branch. And it does that using a constraint solver, reasoning about the expressions in the code. So and in the end, what you then get is a test suite. We have already seen one test case. And by construction, it's a small test suite because PEX only tries to cover each branch in the code once, the then and the else branch. And it achieves high code coverage because, well, PEX tries to cover every branch. I can go down a bit more into the details, Mike, to bring across how that really works. So in this case, PEX actually started from this parameterized unit test. And it executed it with different inputs and monitored what's happening. And initially, it always starts with simple inputs, null and 0. And then later on, PEX will figure out which values will trigger corner cases. And then it will use more complicated objects. In fact, there's a slight twist here. We don't want arbitrary web services, but they should be non-null. Because here, that is a class under test. And we cannot even call process if we don't have an instance. So we have an attribute in PEX to say what is a class under test. Then it's not null. Then there's a call, and PEX monitors the call, what is happening in there. Then there's a branch in the code. And that's why PEX comes up with a test case where the order is null and where it's not null. Then PEX detects the loop pattern, and it will produce tests that use the quantity 0, 1, and 2 to exercise different corner cases in the loop. And then you probably remember we hit this issue with the store. It can be null. And then we get a test case like this, traditional unit test, which sets up the data. And then, in fact, it calls back into the parameterized unit test. OK, so this is how PEX works. And I really want to write a unit test that goes into the business logic.
All right.
But before I can do that, there's a slight problem here. And that is, I need a warehouse. So before, we stopped at this line where the warehouse was null. And if I ever wanted to get beyond that line in testing, I need a warehouse.
Well, go ahead. Why don't you just write one?
That's a lot of work, Mike. And there are many methods to implement. So the good news is that in PEX, we have a framework that helps testing with interfaces. So instead of having to implement all methods of an interface yourself, PEX can generate implementations for you. So the way the Stubs framework works is for every interface, it generates a class. The name starts with the letter S and then the interface name. The class implements the interface. And for every method in the interface, there's a property in the generated class. The property has a delegate type, and here the delegate type is an action of a string and an integer. So the delegate takes a string and an integer. That matches exactly the signature of the method in the interface. Also, the name of the property is slightly name-mangled in order to distinguish different overloads. Now, the way this works is that the implementation of the interface actually simply calls back this delegate property. Yeah? So only those methods which are important for a test case have to be dealt with when we use this stub. So only to those properties we need to attach our delegates as they will be called. And all of these other irrelevant methods that we don't need for the test, we can just ignore.
All right, well, so I don't understand. Can you show me how you actually write those delegates? I'm not sure how that works.
Okay, so let's put it all together. So I thought a bit about the business logic of this web application. And so what I want to say in this test case is that it shouldn't matter what quantity the user specified. We should ship the right amount of items. If the user wants 2 items, we should ship 2. If the user wants 3 items, we should ship 3, right?
Well, I think we'd make more money if we just took their order and didn't ship any, but I can understand why you'd want this kind of test.
Let's start by building some trust in our application, and then we can see later what we do. So as a parameterized unit test, I can say that the following should hold for any order. It doesn't matter what the exact quantity number is. It should work for any order. And then I construct a little warehouse in here using this generated stub. Can you read that, Mike?
Let me take a look. Well, OK, I see the constructor call, and that's the class that you created, that PEX created for me. I don't. What's the next line, though? I don't get that.
So we use a few features of C# version 3 here. So there's a lambda expression, which allows us to write very briefly an anonymous method. So here we are just saying that we want to increase a counter whenever ship is called. Another fancy piece of syntax is that we can assign properties as part of the object initialization. So if we needed more methods of this interface, we can just add more lines to specify what these other methods should be doing. And for whatever method we don't specify, there's some default behavior. OK, then we call the code under test, giving it the warehouse and our order. And then we state the assertion that the number of shipped items should be equal to the quantity in the order. So do you think that code is bulletproof? That's a test that should hold always?
Well, let me take a look. I've already gotten burned a couple times today, so let's take a look. No, in fact, that's the same problem I had in my code, which is that order, the parameter could be null, and then I'd get a null dereference there for quantity.
I think you're right, Mike. So it doesn't really make sense to run this test case for a null order. And that's where the concept of assumptions come in. So there was this question beforehand. So when we write down an assertion and the assertion fails, it's an error. It means that a test case failed. The program reached a bad state. And when we have an assumption and the assumption is violated, then for PEX it simply means that this is an input that we are not interested in. We don't care. And then PEX will filter out that input. Another difference to requires and ensures is that requires and ensures always have to go at the beginning and at the end of a method. I mean, that's where they are checked, although you write them at the top.
Right.
Whereas assumptions and assertions can be at any point in the code. So you can write assertions in the middle of a unit test. You can write assumptions later on. They're really conditions over the program state and not so much a contract on a method.
That's right. And,
So assume is only relevant when using PEX?
right. Right. So the question is assume only useful when you're using PEX? No, so you can think of them both assume and assert, say at this program point, this condition better be true. What happens if that fails? We can make a distinction. Assertions are something that should always be true. And if they aren't, you want to hear about it somehow. That's a failure. Tools can react differently to assumptions. So PEX, for instance, will not generate a test for which assumptions don't hold. The static checker, if it hits an assumption, it says, oh, OK, this is something that should be true, but I don't need to prove it. I'll just believe it as being true. And from this point forward in the program, I will assume that this is something that is true. At runtime, though, they behave exactly the same. They test the condition, and if they fail, it's a contract failure.
Right.
You want to use assumes in your production code.
You may want to use, yeah, that would be your decision. I'm sorry, the question was, would you want to use assumes in your production code? And probably, I mean, it's going to be the same as whether you use asserts in your production code. I mean, it's kind of the same thing.
Yeah, like Mike said, at runtime, both are similarly executed. It's basically a check with a branch. If this condition doesn't hold, something bad happens. Either we will ignore the test case if we run PEX, or it's an error. And PEX tries to cover all the branches in the code. That's why PEX will try to invalidate all assertions and will try to validate all assumptions. It will always try to go along both edges. And that's how we get positive test cases and negative test cases.
I think we should go ahead and let's do it. Let's show it.
OK, so let's do that in Visual Studio. So in the generated test project, I already showed you the file holding the generated test cases, the unit tests that don't take parameters anymore. There's also another file that I didn't show you yet that holds parameterized unit tests. And you should edit the parameterized unit tests, writing assertions in these scenarios. And the other file is generated, and you normally don't want to edit or even look at it. OK, so in this file is the little stub that I showed you earlier. That's what PEX already created behind the scenes to start the exploration. And I already prepared the parameterized unit test we just saw on the slide. Here it is. And so that's exactly what we had on the slide. It almost compiles. I need a using clause for code contracts. They live in their own namespace. And the warehouse was magically generated by PEX in the background. So we have now an SI warehouse class because we had an interface with that name in the implementation. And it's generated in a sub namespace, so I have to add another using clause. Now it should compile, and I can launch PEX on this parameterized unit test. So you can run PEX on either directly the product code, if you want to get test cases for a particular method there, or you can run it on a parameterized unit test. OK, so invoke PEX here. Now PEX will figure out which order parameters trigger interesting behaviors. And so what we get is that everything works nicely if the quantity is 0, 1, and 2. And then we actually get an assertion if the quantity is this value. Do you have any idea what might be happening here?
Oh, I know something special about min value. It's negative. So what happens when the quantity is negative?
So when I double click, it takes me to the assertion that was violated. So apparently, this negative value wasn't equal to count. Actually, I can expect that because we are only incrementing count starting from 0. So we will never get to a negative count here. Our loop here starts at 0. Yep.
Yeah, so we didn't even go in the loop at all, right?
Yeah. So I mean, we can never ship a negative number of items, right? It just doesn't make sense. So we have learned that with assumptions, we can filter out test inputs that we don't really care about. So I think I can just prevent this problem by adding an assumption here that the quantity should be non-negative. How do you like that?
I'm not so happy. I mean, what we really found here was a bug in the product, right? It's not trying to make the test code execute correctly.
Really a product bug?
I think this is really a product bug.
Oh.
I really think that we shouldn't have quantities that are negative.
I mean, it's never so clear when you hit a bug. Is a test case testing something that is irrelevant, or is it a product bug? That's good to hear that it's a product bug.
So I think what we should do is change the constructor for order so that we never allow orders that have a negative quantity. The question was, why would we ever want to allow a 0 quantity?
We can make that greater 0.
That's a great question, and that's exactly what happens when you write contracts, right? So a lot of times these things just go in the code, and you look at them later, and you're like, well, was there a good reason that it was 0 or not? And when you write contracts, it's staring you in the face, and that's exactly what you have to start thinking about. You say, no, yep, you're right. Maybe I don't even want 0 quantities. Right? And now it's much more explicit. When I come back and look at this code next month, next year, when somebody else comes along and looks at it, they really understand what the intent was when I wrote it in a much more explicit way than if they have to just sort of go through the logic and say, oh, you know, at 0, something bad happens or doesn't happen.
And what's, OK.
Is the ability to insert a descriptive message explaining that into the contract?
The question is, can you insert descriptive messages into the contracts? Yes. yes, you could put an extra string there, but the thing is you're probably not going to want that evaluated all the time. So it's important that it's just like a literal string, right?
Also, what you get from code contracts, which you don't get with normal, if not condition throw statements, is that the condition that is written as an expression is actually picked up by the contract tools, and the exception that is thrown, if it fails, embeds this expression text, right, Mike?
Right. So you don't actually need. Maybe that's what you're asking. You're saying if it gets violated, you wanted something like
Just
to tell-
duplicating.
like that.
Documentation say, 0 is not relevant.
Yeah, so you can certainly add a string. The condition text itself, the tools will actually, as Nikolai said, generate that for you into the error message.
Okay, so can you run PEX again? So PEX should analyze the test code, the product code, and all the contracts in here, and not generate an illegal order again.
All right, is it hard to run PEX? What do I-
You just go back to the user interface.
oh wait,
and
you told me this, but I have
there's
to
a-
make sure I click this time.
Not debug.
Oops. See, I already messed it up. You shouldn't wait on me. There we go.
Okay, stop the debugger
Yeah.
and press the
Pull
play
plus
button.
play. That's the
It's
button.
very easy.
There we go. So what does that do?
Okay, so the failure is gone, and we no longer get a quantity 0, because we made it greater 0. So we only get 1 and 2. So that looks good. So far, all the contracts you've written, Mike, were rather simple. B said something isn't null, it's greater 0. Why didn't you use attributes for contracts? Why statements in the method body?
So we get that question a lot. So for all the contracts you've seen, it would have been really easy just to have an attribute says, this parameter not null, sort of like what you had in PEX. But let me show you what you can do. For instance, look how that username was null. So I can say things like, username's not null, which is certainly,
We have done that, yeah?
we've already done that. But now I can say more complicated things, like I can say username, its length should be, well, look at that. I just had IntelliSense help me out in writing my contract. I'm not going to get that if I use attributes or if I encode them as strings and attributes.
Yeah, you
So-
cannot write expressions in attributes. You would have to use strings,
Right.
and then you don't.
And then I don't get
that.
any of the refactoring help. I don't get IntelliSense. I don't get compiler support. So we really think that encoding them as method calls in your code is the right way to go. So, okay, so there's a more complicated contract.
Yeah.
Is that something PEX is going to understand?
Username length greater 3. That certainly works for you, Mike.
I thought
So-
all names have to be at
Yeah.
least 4 letters.
You can just run PEX again by pressing the play button,
And not the debug button.
not the debug button.
And let's see what PEX does with that more complicated expression.
There you go. So now you get strings that have 4 characters in them. That's what the contract says. And PEX always tries to come up with the smallest possible test case. So you get characters that have 0-bit set. This is the 0 character.
All right, well, I don't think those are very realistic. I think, if we're fixing the product here and we're making more realistic requirements on the callers, I think we should say something even, more ambitious there. So let's use the link extension method all to say that for all characters in that string, well, they should be at least a letter. That's one place to start.
That looks pretty fancy.
That looks pretty fancy. So now, what's PEX going to do with that?
Just try it out. You know how it works.
Oh, I didn't get anything. What are you talking about? I thought PEX could do all this.
Okay, we have an issue here. So sometimes PEX cannot generate all the test cases you would expect. But then usually there are these yellow issues reported in the issue bar. And then you should look at them. So let's look at the first one here.
All right.
It says something wasn't instrumented. And it says that enumerable all, you remember this extension method that you used?
Yeah.
PEX didn't instrument it. And when PEX doesn't instrument code, it cannot monitor the branches in it, and it doesn't know what test cases it should produce. But it's easy to fix. I just click on it and say instrument assembly. And now PEX will go ahead and instrument system core. That is where the link extension methods are in. So just say apply, and then I run PEX again. Now PEX will instrument the test code, the product code, link, and let's see what we get. So now we get orders that actually have the right username.
Sweet. I like that. All right.
So
I'm
you
pretty
see-
convinced about PEX now.
So PEX solves all your testing needs. You're convinced.
Actually, I'm not completely convinced yet, because I know that I've written lots of code that has dependencies like on the environment, right? That does things that are going to be tough to really be able to debug.
Can you give me an example?
Well, I'm old enough, you're probably not, but I'm old enough to remember the Y2K problem. And that was a problem where code behaved differently when it was the year 2000 came around. And nobody wrote code exactly like what I'm writing, but this is what it came down to, right? It came down to the fact that there was code that somehow was dependent on the current machine time, and it behaved differently if that was the year 2000 on January 1st. And then all of a sudden, your code didn't behave the way. So how is PEX going to ever figure out that, that code is going to behave badly?
I see. So we have a unit test that says in the assertion that we should always ship as many items as requested, but on that date we wouldn't. So can PEX find this assertion violation? And I'm afraid that out of the box, PEX won't. So PEX doesn't have a concept of machine time or an external database or a network. External dependencies can behave in any way they want. PEX only can monitor .NET programs. So we don't find the error. PEX still produces happy test cases as we don't have the 1st of January 2000.
Probably won't ever again, as a matter of fact.
Yeah, unless our year rolls over. Okay, so what you just showed me was really just one instance of the problem of dealing with the environment and dependencies. So it doesn't have to be a static method or property like you showed me, but whenever there's a sealed class in some library that you're using or constructor that isn't public, then you're dealing with code that isn't testable. So to get around this issue, I think it would be nice if you could just convince the .NET environment to be able to redefine what it means to execute datetime now for testing purposes. I mean, datetime now is a non-deterministic method, and for testing, we really want to make it deterministic and say what it should return. Unfortunately, I cannot do something like that in .NET. So I cannot just say that this method is now redefined by some delegate. But the good news is that PEX comes with a framework called molds, which allows us to do just that with 4 more letters.
No. Moles has 5 letters.
Right? So we need 1 letter for the character M that we prepend to the class name. And then we do some name mangling for all the methods. So here it's now get, 4 letters.
Oh, I see. So this looks just like the kind of delegate that you installed for the interfaces.
Yeah, it's very similar to the interfaces we generate with stubs. But this is not for interfaces, but for existing classes and structs. So for every class and struct, we generate a class that is prepended with the letter M. And for every method and property in the existing class, we generate a property that has a delegate type. Here it's a func that returns a datetime. And then when you attach your own custom delegate to this property, then magic happens. PEX will redirect all future calls to your delegate. So just as PEX can analyze all the code from the test to the product code and the contracts, PEX can redirect a call at any place to your delegate. So I can put this all together now. This is the unit test we had before. And all I have to do now is add a line that redirects datetime now as we discussed. And then all calls will be detoured. How will they be detoured? So we don't really have to hard code the value that we want to return, because it shouldn't really matter, right? You put some magic number in there, but it shouldn't matter.
That's right. I really would like it. I mean, I don't know that the code's going to misbehave on January 1st, 2000. I just want to know if there is a date dependence in there. So I'd like PEX to figure out what those dates are for me.
Yeah, the code should work correctly regardless of the time. And that is exactly when parameterized unit tests are good. So I just copied in the unit test from the slides, the parameterized unit test. And so I say that it shouldn't matter what the time is, PEX should figure it out. Now this almost compiles, but the M class isn't defined yet. So datetime is defined in an external assembly. PEX doesn't pre-generate all these M classes ahead of time, doesn't know what you want. So we have to do one more step. We have to add an item to the project. And so after you install PEX, you can do that too. This item is called stubs and molds for testing. So I do that. Then we get a new file in our project, a stubx file. It's an XML file that allows us to configure for what exactly we want stubs and molds. And I looked it up. Datetime comes from an assembly called mscorelib. We don't want stubs, so we can configure that we want to disable those. But we do want molds, and in fact, I want them from the system namespace. That's where datetime lives, and I want datetime. Okay, now when I save this file, then a code generator kicks in, and it generates these M types. So there's a progress bar. Okay, done. And now we have a new reference in our project, mscorelib stubs. That's where all these M types live. And now I think we should be pretty close to getting this to compile. We need one more using clause. And again, it's in a sub namespace of the system namespace where datetime comes from. And now I should be able to just run PEX on it. Now PEX will redirect the call, analyze the code, and figure out what are interesting orders and times to trigger all the different behaviors.
So it's going to just generate lots of different values for that parameter now.
So
Let's see what it found here.
PEX will look at the branches in the code, and yeah, so let's see. So there are 4 test cases to that pass, as before, because sometimes it just works.
Yeah.
But then there are 2 test cases, and look at the time, where we get the assertion failure. So PEX looked at the code to figure out that this is a magic date. We didn't have to do it. So are you convinced that this works?
I think we should do it.
Yeah.
All right, so I see that, but I'd really like to, can you just show me, I really want to see the detour happen. I want to see that it actually calls your thing instead of date time.
Okay, so let me just start a debugging session here. So I want to break into the delegate, and I use a generated test case to go there. Here you see a bit of the generated code. Normally you don't want to look at it. Yeah. Okay, so we are now in the debugger, and let's look at the stack trace. So at the bottom, we are running our parameterized unit test. We're going into process. Then one level up, we are about to call datetime now. And we see in the stack trace that, well, yeah, we are about to call datetime now. But then actually, we end up in the redirected delegate. And we can look at the values live in the debugger. So PEX really detoured the call.
Amazing.
It's fully
That's pretty
debuggable. Okay. I think we are close to the end.
I think we're almost done. We just want to summarize. So the contract library itself ships in .NET 4.0. So inside mscorelib in the namespace system diagnostic contracts, you'll find the contract class. However, all the tools need to be downloaded from DevLabs. We're going to show you where to get that in just a second. From DevLabs, when you install it, you'll get the runtime checker we showed, the static checker, you'll get our documentation generator. If you're not using Visual Studio 2010 yet, well, besides feeling shame, you can still use our contracts because we have a little standalone library that defines the contract class for you. And then very soon we'll be shipping the Visual Studio 2010 editor extensions that will show you the contracts in IntelliSense and inherited contracts.
You also have to download PEX separately from MSD and DevLabs. And with PEX, you get the ability to write parameterized unit tests. So you have to write less test code, and you get more out of it. Just think about it, how many unit tests you would have written here. Maybe one where the quantity is 0, one where it's 1. Then you would have missed the negative case.
Yeah, I would have missed the negative case.
And then PEX generates a test suite that is small in size and high in code coverage because PEX tries to cover every branch once. And PEX comes with 2 frameworks that makes it easy to test in the presence of interfaces and legacy code.
We've mentioned DevLabs a couple of times. In case you haven't seen it yet, DevLabs is a site that Visual Studio is running where they're making advanced technology from places like Microsoft Research available to you to get your feedback. And based on your feedback, they're going to make the decision about whether or not these are products that they want to include in the box in future versions of Visual Studio. So PEX and code contracts are just 2 of the tools out there. We encourage you, before the talk's even over, there's the URL. I'm sure you can go there and get it downloaded and installed before we even finish.
Yeah. So right now, Microsoft Research is developing these tools, and we need your feedback so that it might be in the box one day in the future.
So there's forums for every tool that's out there, and there's quite lively traffic on the tools. And if you post on the forums, you'll get a response quickly. You'll be able to get help and feedback. Thank you.
We also have a booth. So it's in the big room with the other exhibitions, and you find us in...
If you go to the back right corner, you'll see us at that little black dot right in the middle of that circle. And please come by, see some more examples, get a chance to play with it yourself, and ask as many questions as you'd like.
Okay.